Get started then. So, Alexandra, I guess we should start by the beginning. Tell me a bit about your story into R, how you got into R, and what motivated you to apply optimization and teaching and so on.
Yes, well, thank you, and thank you all for this opportunity to speak. So I was at University of Chicago as a math major for my undergraduate work. Chicago is well known for sort of its great books and not well known for its engineering. So I liked math, and that was sort of the option there. But I was always looking for things to which to apply it, and even the applied math at Chicago, especially in that time, was a little theoretical. So I had taken some statistics courses and I took some economics courses. I even took a geo physics course in inverse methods. I was always looking for like how is this math being applied. And eventually I took a class from Kip Martin in the business school. He's an integer programmer there, and he's got a famous large-scale optimization, linear optimization book out. And so he was the one who first introduced me actually to optimization. And so when I saw him put on the board linear programming in 2 dimensions and he did the graphical representation, and I said, this is exactly what I'm going to do. So that was my senior year of college actually. And so I found that. But I think that I like the modeling aspect of mathematics more so than I like the theorem proving. So I was motivated to try to take all that information that we learned from algebra up through differential equations and everything in between, and then learn some extra math and really apply it. So that's sort of how I got going in the field.
Okay, that sounds like a lovely story. For me personally, it was more or less the same. Um, yeah, everything clicked in my linear programming class as well, so that's what got me into here as well. But specifically, what drew you to teaching optimization?
So I think it was maybe a confluence of events. I mean, I became an optimizer in grad school. I also come from kind of a line of family members who teach. So my parents were classics professors, so that's actually Latin and Greek. It has nothing to do with optimization, although they can derive all these words that we use. So I suppose that's important. So I guess just having that teaching from my parents plus the optimization, and then also my grad school advisor, Professor Candiano at Berkeley, was very influential as well. At first, I thought I was going to go into industry, and she kept saying, "Oh, why don't you do this because it will look good for when you look for an academic position?" And I, started thinking, "What's all this when? How about the if?" And she sent me to an NSF-sponsored workshop at Carnegie Mellon, which was very nice as well. There was the Informs academic workshop, and so I think, as I kind of went through grad school, I became more resigned to the fact that maybe I would go into academia, and that's really all I knew from my parents my whole life. And so that kind of led me into where I am today. I also add, so my first appointment out of grad school was at Naval Postgraduate School in the Operations Research Department. That was very good. They do a lot of applied modeling there. And so I was 2 years as a research assistant professor, learning a lot of military applications, still working a bit on getting my papers out from grad school. And then my advisor again said, well, Gene Woolsey is at the School of Mines. I see there's a position open here. I think she said he's a little eccentric, but you guys would get along. And she knew I loved distance running, and so Colorado is a great place for that. And so she said, well, just apply for the job. And so that's the only place I applied, and I got it. And so then that's why I came to School of Mines. So yeah.
Do you think this is more of a personal question, an interesting one to me? Do you think it had an impact, the role of your parents as classic professors, within your own role? Like,
Oh
were
yes,
you influenced?
I'm sure it did. I think that kids tend to sort of absorb things their parents do and say, and so in that sense, even if it's implicit, there's some influence behind that. And I remember my father saying once, he said, "Well, academic life is good life. You have time." And I thought, I was about 8, and I'm like, "Well, we all have 24 hours in the day. What are you talking about time? Like we all have time." But you kind of learn to think, well, but of course you do, but you have a little more say in how you're going to use that time, and that's the really important thing because that's obviously the biggest commodity we have. So.
Yeah, definitely. But, you are a teacher in teaching optimization, but you specifically you were drawn to it by the applied side of things. So now I'd like to ask you specifically about applied optimization, teaching it specifically. As you may know, and as most of every one of the attendees should know, there's a clear gap between what we see in academia and then what is applied in industry. So I'd like to hear your thoughts on this specific gap.
Yes.
Yeah,
Yes, so I think the gap has quite a few dimensions. One gap occurs in the classroom, and then I think the other gap sort of occurs outside the classroom. So I'll start within the classroom. So I obviously think the theory is very important, and even for somebody applied like me, we definitively talk about methodological developments. We talk about algorithms. I love to kid with my class that I was talking about algorithms way before the media and everybody was talking about algorithms. And I teach six, hopefully soon to be seven courses in optimization. It will soon be two courses in nonlinear programming, two in linear programming, two in integer programming, and then in networks models. And we talk about algorithms all the time. I mean, everything from shortest path, it's some Dijkstra's and label correcting algorithms up to, primal simplex, dual simplex, interior point, branch and bound, and beyond. So I don't at any point want to disregard the theory. And I always tell the students that even if they're sitting in a class with theory and they think it's really esoteric, I'm like, I cannot tell you how many very important methodological and computational developments have come out of theory that were seemingly useless at the time that they were developed. And all of a sudden, somebody put A, B, C, and D together, and there's some confluence of events, and that led to, the use of widespread use of Gomery cuts, for example, in
yeah,
branch and bound.
exactly.
I want to preface what I'm about to say with the fact that I in no way, shape, or form want to disregard the theory. And I always like to emphasize, especially to the engineers who don't get much theory at the School of Mines. But that having been said, I do see a lot of students in various courses, whether it's my institution or beyond, where the faculty seem to stop just at the theory. It's comfortable. They don't need to deal with the computer, and they don't need to deal with, the latest software developments, the upgrades, getting students on the system, and so forth. And so, the analytical work is kind of, where the teaching ends. And I've always been adamant since I started teaching that the students would learn some software and they would learn how to compute. And so when I came to School of Mines, Excel was a little bit of a thing. And I for a while used that in survey courses because I thought, if they need to learn something about crystal ball and something about integer programming and something about queuing theory, I mean, how are you going to put AMPL or a good modeling language in there as well, right? But I don't teach the survey courses anymore. I just teach
Mm.
sort of my more hardcore focused courses, and they're kind of I would say advanced undergrad slash grad student courses and then PhD. So that's the level I'm talking about here. And and I always teach a modeling language, and for consistency, I always teach AMPL. And so AMPL pervades every single course. And so every single class, I always start with formulation. Every single exam, I always start with formulation question as well. And we go through, maybe 3 or 4 weeks of formulating models, and then I slowly start introducing them to the software. And they get some extra help. We have a help session on Friday. I call the extra helpful help session. So if they're not comfortable with the software, they go to the extra helpful help session on Friday. By its name, I'm trying to entice them to, thinking a certain way about the help session. But we also, that gives me a chance to introduce the command line to them. Some people have no idea about the command line. And so I think that's an important tool as well. So now some of them use IDE and they use AMPL in other formats, and I introduce them to the website. But we start then solving the models we've been doing homework problems on in the first few weeks of the course. And then throughout the course, every week after about that fifth week, so for about the remaining 2/3 of the course, I continue to give them at least one formulation on the homework, even if I'm asking them questions about the simplex method or questions about sensitivity analysis or branch and bound or cutting planes, whatever the course is, we always have at least one formulation. And I always make sure some of the formulations have numerical values in them so they can actually plug it into the computer. And so throughout the remainder of the course, they will be solving at least one, if not multiple questions using AMPL and a solver of their choice, or appropriate solver, for the remainder. So nobody gets out from the class without knowing
Without knowing
something
how
about
to model. Yeah.
model and solve the problems. And I think that's important because when I was taking, my first class in linear programming, there really was no AMPL. So, I had some like Lindo software from University of Chicago, Linus Strage, on on a floppy disk. And they said, well, solve this problem. And so I kind of put it in the computer and, I did something. I managed to get a solution. And I was thinking, how on earth are other people supposed to get this done if they hadn't had, some something like that. But there was no sense of like actually teaching a modeling language. Now, that was under Elon Adler, I might say. And the way I got involved with AMPL is that a couple years into grad school, he handed me the book, which I still have, the first edition of the book, and the AMPL, and he said, "We'll be using this year. It looks kind of interesting and like a useful tool. Here you go. You can teach the students." And so that's how I learned AMPL. But I thought it was a valuable tool, and I continue to think it's valuable. And so then when I was in charge of my courses, I put it in, and we've been using it. And so to get back to that question about the bridging of the theory and the practice, if you're not learning a modeling language and you're not learning how to solve problems, you're not really getting into the practice of it. And it's not just the modeling language and solver. I mean, AMPL has very good scripts for Lagrangian relaxation, Bender's decomposition, and otherwise, and we go through those in my various courses, and I show them how it's more than just a modeling language; it's a whole, coding tool. And of course, I grant that there are other tools out there. Some people will use GAMS. That's prevalent, I think, for economists and electrical engineers. But I like some features of AMPL very specifically. I thought a lot about it. I know other modeling languages, and there's some things in AMPL that are very good just in terms of how close the math is to
What
the.
specifically do you like about Ample? Sorry for interrupting you, but
Oh,
I'm
yeah, yeah, yeah.
curious.
No, I can. Well, I mean, first of all, many of my students will say that the math you write down on your piece of paper and the code are fairly, they're fairly similar. And so it's not a huge leap. And in fact, even without knowing much about AMPL, if you just sit and look at it, you can probably read it even if you couldn't generate it. So that's one thing the students say they like a lot. I really like the emphasis on some of the like minor pedagogical things, such as, variables non-negative. Yes, you have to write greater than equal to on your computer, but that is very important because there are no strict inequalities in optimization. And so having to write that down just emphasizes the math. I also think the use of the sets, the index sets, that's all the tuples you can put together. That is really good for efficient formulation. So you're not generating every I cross J cross K instance of your formula, your variable. So that's very good. The fact that it's case sensitive is huge. If you're going to do a Bender's decomposition and you want to take your variables from your master problem, fix them in your sub problem, for example, your integers, then you can just call like little y, maybe your variable in your master problem, big Y, your parameter in your sub problem, and that's super nice,
Yeah,
right? The
yeah, we have seen
suffixes,
those
yeah, yeah.
implementations.
Yeah, exactly. So you don't need to call it YY or something like that, right? So that's really good. So just the scripting in general is good, and I just think it's very clean. There are some modeling languages where I feel that it creates a little bit of sloppy math, and I feel that AMPL does not let you do sloppy math. And as a math major undergrad, and just knowing things about sets and so forth. I mean, this element has to belong to this set, And so I think early on when I was using AMPL, I'm like, why can't I do? And as I became more sophisticated, I'm like, well, of course you can't, because
Those
mathematically
rules
that's not
make
the way.
sense.
Yeah. And I think
So
that's really important to emphasize with the computer that this is still math. And if you're not precise in your math, then you're not going to be precise in the computer.
exactly,
Um,
you will get wrong results and so on.
yeah. Yeah, and you just don't know what you're saying. You could, even if you got the right results by accident, you couldn't justify why they were there. Expand command is super big. I love that. All the interfacing with the different solvers is super huge because, as you can imagine, especially nonlinear optimization, I like to give the students options. Groby now, of course, has made huge strides, but a few years ago, Groby and Cplex, they weren't not
They
tools I would
weren't
have.
able to, yeah. How
Yeah,
valuable is it to you, the ability to connect to all of the different solvers?
and that's super huge because then I can just use AMPL for every single class I teach, and I don't need to worry about it. And I can also I can also tell students, look, it's true that Cplex and Gurobi come with higher price tags and Express and so forth. But if you can find a free solver that will do the trick, here's your AMPL code, and you just hook it to the free solver even. And so I think that's really good for them to be able to, both from a maybe computational heavyweight perspective, just what they need for their computational machinery perspective, and then what their budget can handle, they can kind of try things out. So I think that's extremely important. Yeah.
Okay.
So to get back to all of that, learning a tool like AMPL in the classroom is extremely important to become a good practitioner. And if you're not learning a tool, you're not comfortable with the tool, you're not able to go to a company and say, this is what we should be using, And I'm going to justify the cost because now instead of using Python or another general purpose package or some freeware, I'm going to use something that's already been vetted, and where the development time and the debugging time is very low. So you're going to save in spades, right? And if you don't have all that and you can't make those cogent arguments, then I think that you're not, you're spending your time in a lot of minutia you should not be spending it in as a practitioner. And one other thing I want to emphasize about AMPL
Mhm.
is that I have talked to Bob before about this, and we haven't quite gotten it over the hump, but I know that there have been companies have used AMPL, and they worry about security. But AMPL does all that for you. So if it's free and you're updating certain packages all the time with certain other softwares to remain nameless, then how secure is that for a company? Wouldn't you pay a little bit of extra money? You probably would even save on some insurance your IT has to procure for you if you say the software we're using is actually always being upgraded and we have those secure patches in place and so forth. And so I think people don't even think about that utility. Um, so that's inside the classroom. I do still have an outside the classroom answer if I haven't gone on too
Exactly.
long with that.
Yeah.
Um,
Okay. To me personally, I would like to emphasize as well on that everything you have said so far resonates with me. The first linear programming class I took, we modeled in Excel,
yeah,
which wasn't a very nice thing to do.
yeah,
For the capstone project, we had to model a TSP of California cities and so on. So it got extremely big, extremely quickly. So we couldn't model the TSP in Excel, right? So now the
right.
question is, okay, how do you properly solve these big problems and how do you model them? So that initially drew me to modeling languages and so on. And it was hard because throughout the course we didn't learn a modeling language, right? So it would have been very useful at the same time to have been learning AMPL or any other modeling language to properly solve these problems. Because
Yeah,
at the end of the day, the computer is doing the heavy lifting, right? But you need to properly be able to let the computer understand and know about your problem. And the mathematical rigor provided by AMPL, as you're saying, is a very nice way to properly
yeah,
introduce the problem to the solver as well.
yes,
So yeah,
yes,
totally
yes,
everything you have said is on point so far.
yeah,
Okay, so now I would like to hear about your outside of the classroom part of
yes.
the answer
Yes,
specifically.
absolutely. So I think that the kind of outside part is it's very good if faculty develop relationships with some kind of companies, and it's not easy and it's not maybe feasible to do this for all students. But there are a significant number of my PhD students actually have experience working with an industry sponsor. And the federal dollars are nice and we appreciate them a lot, but having an industry sponsor actually say, I'm using this is, I think, very important because you start to get into a lot of things that it's I would say difficult in the classroom to introduce. For example, just trade-offs of time fidelity or spatial fidelity, or the fact that the data is never going to be what you want. And I tell the students all the time, I say, listen, nobody made this data set for your optimization model, right? I mean, they made it
Exactly.
completely divorced from the fact that they were ever going to optimize anything. They don't even know what you're doing with the data set. They don't even know what optimization is. So when people complain, the students complain. I said, well, this is really what you're going to be handed. And so I think that having some sort of a relationship with some companies to wade through the data and also have them change their mind all the time. I mean, we're working with a specific heavy industry partner right now, and they just developed some new rules. It's like, well, we've been working with you for a while. Why are these rules so new all of a sudden? So I think that really having to get into that, and it's not just on the onus is not just on the faculty, it's also on industry to see that they could actually save a lot of money by working with academia, buying some software that made sense, and partnering with them. And so anything to try to bridge those gaps is very important. But it really comes, I think, from both sides. But I think there is a big disconnect between what people are learning in the classroom, even if it's a research that they're working on, even if it's really pretty high level or kind of intricate mathematically. It's not the same. I mean, it's the same thing as speaking a language, right? I mean, you can learn in the classroom all you want, and then you get flung into the country where they're speaking it, and all of a sudden there's a slang that you don't really know, and there's ways of saying things in different contexts, and you can say this in this context, but not that one, and you just have to be in it, right? And so. That's what I would say. I think there needs to be a little more of an emphasis, if possible, on faculty actually going out and establishing those relationships and the industry being open to those relationships, hopefully because maybe some of their alumni went through some of these programs. So,
Definitely. To me, I come from a software engineering background, so it's hard because I have seen some of my colleagues, specifically coming from more research backgrounds, mathematic undergraduates and so on, or
yeah,
industrial engineers as well. And there's a very clear gap between running, your Python script, which contains your Gurobi Pi model, for example, and then properly taking that into production.
yeah,
There are tons of missing steps and knowledge that basically no one teaches you in the classroom
yep,
about how to properly deploy, about the software engineering topics, about the user interfaces, working with the data, as you have said. Data is never clean, data is never nice. You always have to pre-process it, clean it, engineer it in sort of a way that your optimization model can handle. And
yeah,
no one teaches you that,
yeah,
specifically in these courses.
yeah.
So that's the gap exactly, and we should probably then figure out a way to close this gap or at least try to make it more manageable for students, but also for industry. As you're saying, there are two sides to this coin. One
Yes,
is the academia part, and the other one is the industrial partners. What can we do? What can they do in order
yes,
to properly bridge this gap as well?
yes, yes, yes.
So specifically talking about some of your industrial partners, do you have any specific example of an assignment, a project, or a capstone project that helped your students bridge this gap? Or even a research project applied in your PhD students?
Yeah, I think more so than kind of capstones. I don't run like an MEng program or undergraduate program. So it's really our industry partnerships are more with the little bit the master students, but mainly the PhD students doing some work for what will ultimately wind up in their dissertation. So sure, I can give a couple examples of companies with whom we work and what has come out of it. So one company we work with it's a mining company. They have deposits internationally. And so they're interested in a wide variety of things. And we did a project for them in underground production scheduling. And it was a little bit odd because we've done underground production scheduling before. And so this involves determining sort of which activities, these notional activities that must be done, which of them are done when in order to adhere to precedence constraints regarding the sequence of operations, and then also these knapsack constraints regarding the amount of resource you have per time period. So you have so much ability to do blasting or mucking or backfill, extraction, and these kinds of things. But the question was really quite a bit different. The spatial fidelity was really fine that they wanted us to use. And so that led to, as you imagine, many decision variables, both in space and then also temporally. And so really they were more interested not really in a sequence of activities or a production schedule, but more in what kind of spatial fidelity should they use in order to make a reasonable trade-off between the actual kind of schedule and what each activity would render in terms of the amount of ore contained in a particular extraction activity, and also just what was solvable. And then they were also interested in trying out different kinds of software. They had Garobi, but we had some tailored software from our Chilean colleagues, Marcos Goicolea,
Yeah.
and them
Alicante
at
folks.
Alexandra.
Yeah.
Yes. So it became sort of a different question about model size almost, and kind of strategic questions than about capital investments, and less so about the sequencing. But they now have another question. This is open pit now, and they're routing their haul trucks from where they come out of the pit to these various sites. There are stockpiles, there are dump sites, or the material taken off to mill. And what we got there is just like 3 million points out there in space. And that's just the topology of the surface. And so we're working with a computer scientist. He's very good in graph theory. And the notion was, well, how do we, first of all, just depict these points? And then there are things about these Delaney triangulations. And like I say, very graph theoretic work in trying to put these, points together in a way that makes sense where you have incorporated enough spatial fidelity, but not too much. And then how do you do the routing? It's kind of shortest path, but the cost function also pertains to the turn radius and the grade. And so some grades and turn radii just are incompatible and they have to be left off the graph, and then some can be incorporated with a penalty. So, but it's a lot of back and forth in terms of just the data set and how big should the data set really be, and this is how we're cutting it down. Is that okay for you guys? And then features they want. So that's one, and then another one in heavy industry that we've been implementing is with the steel mill. We're
Sorry
still
to
very
interrupt you on that, but maybe
yes.
we should include some of those instances of the routing problem into the mind lib as well. Sounds interesting.
Yes, that's right. Right now, the Mind Lib. So this is for those listeners who don't know. This is the mining library. So my Chilean colleagues and I put together a library. This is 10 to 15 years ago of open pit mining problems, and people have gotten on the web and tried to, use these as test cases for their algorithms and so forth, and heuristics they might be developing for open pit. So we're trying to refresh those examples. We're trying to refresh the model formulations to include more sophisticated features such as stockpiling.
The stochastic
um,
optimization.
Exactly, in stochastic optimization. And then we're trying to include some underground data sets as well. So Eduardo is going to be helping us in this endeavor and going to be a co-author on the next paper, and he's put together some interesting sort of ability to code these to make it easier for the practitioners so they don't have to come up with their own code around the data files that we currently have. So we have not done anything with routing on the surface, but that could be a thing too.
Yeah,
Yes.
that could be a thing. I know you are really excited about the steel mill application as well, but let's leave it. If we have time, we should talk about it later. But
Sure,
for now,
absolutely.
I'd like to move on your perspective specifically as the editor-in-chief of the Informs Journal on Applied Analytics. And before you start, I just want to show you something. I think this is a copy of the Interfaces Journal. They gave it to me at my first job. It's the 2007 March and April edition.
Yes.
So it's this is the only physical copy of a journal I have, and it's now the journal that you are the editor-in-chief of. So the world works in mysterious ways.
Oh, wow. Well, and that was back when it was called interfaces. There was a push under the former EIC to make it a little bit more, I guess, modernize the title. And so it became Informs Journal Applied Analytics. So we have Informs in the name, which is nice, I would say, because it is an Informs journal. So yes.
So for the
So
audience, just a little bit of context, the Journal on Applied Analytics is basically an Informs journal in which practitioners are encouraged to upload and submit their ways of working with optimization, with analytics, and how to apply this properly in the context of their own endeavors. And Alexandra is the editor-in-chief. So I would like to hear your thoughts specifically on any trends or gaps you may be seeing as you sift and read through all of these manuscripts and papers using applied OR and analytics.
yeah. So I would say, so I'm going to first answer with the way everybody would answer, which is that, of course, we see more things with AI and machine learning now. And whether it's a paper that almost exclusively uses it or it's a paper that employs it as part of something else, I would certainly say that yes, that certainly is quite prevalent. Um, I would say, though, in general, that just the interdisciplinary nature of the work is going to be more prevalent. So I would say that maybe 10, 20 years ago, you might say, well, here's my queuing model or here's my optimization model. And so there is certainly a trend towards sort of the use of maybe infusing one with the other. Um, I would say the models are larger scale than they have been in the past. Not entirely. There's a very impressive early work, people using decomposition schemes and so forth to get large supply chains with multi-echelons, for example, to produce some sensible answers. But in general, I would say that yeah, just the scale of the work and the different types of methodologies employed. Of course, also there's always the trends in application. So a lot of transportation models and maybe some financial planning models early on. So you see a lot of linear, linear integer, and maybe quadratic with some of the financial models early on. And now you see well, of course, since COVID, we have a lot of COVID papers. Everybody's dealt with COVID their own way. But there I would say is also preponderance of different kinds of topics. Still, supply chain is, I would say, very prevalent. We are engaging with some tutorials, and people have written some things in like large language models. We do also accept tutorials, so things like that. And Yeah, just I would say, well, we certainly had some mining work be submitted, supply chain with agricultural implications. Another nice thing I would say about the journal is that, of course, it's been very North American centric. And now I feel that it's actually, we do get submissions from around the world. Some continents are better represented than others, but I do definitely kind of look for that as well in the journal. And so I think that we're seeing submissions from most continents now, all continents really. So that's nice to see.
Yeah, that's that's a nice journal. We have applied, we have submitted something, so
Yes.
waiting for that. So we are reaching more or less the end of the allocated time. So I would like to conclude with the closing question. This is a very broad question, so I know you will take your time. But to conclude, what is one piece of advice you will offer to someone, a student, a faculty member, a practitioner, who wants their work in optimization to have real world impact in a sustained way?
Yes. Um, well, so I'll answer it tersely and then expand on it. I mean, my terse thing is you need to be a drummer, right? So there's a lot of lead singers out there, right? And they're very flamboyant and so forth, and the guitarists, and they have their solos all the time. But really, I think that you have to be the drummer in the back, just constantly, you got to have a lot of persistence. And you need to really think about things really calm, cool, level-headed approach to it. You can't kind of give up. I think we're working with an hopeful industry sponsor right now. I remember one of my high school classmates, I was complaining to him about this, and he said, you have to be persistent. And that's really true. And I think there's a lot of times when people want to give up, or, they really don't like this data, or the company changed their mind 14 times, or, they don't want to buy the software initially, and, they want to use something that's general purpose and so forth. And I mean, you can't let that sort of, I don't know, get in your way of just saying, all right, well, let's go back at it. All right, what are these new rules now? What data do you have if you don't have this other data? What are the best tools? But I think a lot of it is really just sort of hanging in there. I mean, I think that's true of a lot of research. I remember Kip Martin telling me, he said, oh, some people will always just say, well, that, theoretical research is hard. And he's like, applied work is also hard. He's like, all research is hard. And that's it. I think whenever you're doing something people haven't done before and you really want to make an impact in a novel way, you really have to be persistent. So
I think that's a very good piece of advice. I hadn't thought of it before, but it totally makes sense. So thank you very much for that pearl of knowledge. I will be keeping it in my mind. So we have some questions from the audience. Ina, I don't know if you would like to.
Yeah, absolutely. Thank you so much. It's been really, really informative, and I feel that there needs to be a part two to this conversation. I'm not sure we
Definitely.
really got into as far as we would have wanted to. Alexandra, it's been great listening to your perspective on all these topics related to OR. So going just straight into the questions here, just so that we can keep ourselves on time. We have a question from Mahesh. He says, thanks for this talk. Can you share any specific resources, books, papers, etc., to bridge the gap between problem formulation and how to go about thinking about formulation large scale or formulating large scale problems, which are way more complex than textbook models? How to close this gap?
Yes, so on the I guess on the side of kind of more how would you formulate the model after it's already formulated, maybe reformulation, cutting planes, use of software, and so forth. Ed Klotz of Garobi, back when he was at CPLEX, and I have two sort of twin papers. So it's Klotz and Newman, and those would be from about the 2013, 2014 time period. And that has to do with practical guidelines for solving difficult linear and mixed integer programs. And those are in the surveys for operations research and management science. You can also send me an email and I will send you the papers. So that's a little bit less like actually how to formulate, but more when you have your formulation, if there's a reformulation that might make sense or how to solve. There's another paper out there somewhere being generated in the nonlinear realm as well. So that just focused on linear and integer at that point. Then I would say as well, there are some papers, and I'm happy to maybe supply some again if you send me an email of well-formulated models. So if you say I'm interested in, this particular application area, I could probably say, here's a couple papers that actually have the tenets of what you're looking for, some of the same objectives and constraints, and this is a good formulation. And just formulating itself, going from textbook to paper, I think that's a little more difficult. But like I say, I can help tailor an answer for you depending on your application. I think that's the best thing to, yeah.
Thank you, Alexandra. So the next question is from Matthew. How significant of an impact is expected to publish applied work with companies? Is there a certain amount of financial benefit or other baseline expectations to get the thumbs up for acceptance?
Oh, I see. So I'm assuming this is in the Informs Journal on Applied Analytics,
Yes,
then.
yes, it's around that.
And there is not like a minimum level of savings or anything like that. That'd be in any kind of quantitative amount. The thing is, the model has to be used, and we published a paper on these magic numbers for the NBA. In full disclosure, we have yet to engage with the NBA. But the numbers were certainly used because we had a website and we could see people going onto the websites and looking at the magic numbers. And that was sufficient to get the paper accepted in the journal. So I think you have to show that the model has been used to some, benefit, but you don't necessarily need to say that there's some huge monetary savings. And sometimes it's just a savings in time, or sometimes it's just providing people with, some entertainment for the fans, about what their team is likely to do, and so on. So I think that it's a fairly flexible bar, shall we say, but it would have to be used. It'd have to be some documentation of the use of the model. Yeah.
Wonderful. And one last question here, unless we have another one popping up in the next minute or so. And it's from Marcos. Why do you think operations research is not a well-known field compared to other applied disciplines like statistics, machine learning, etc.? And how could OR be boosted?
Yeah, well, that is a good question. And that's actually a very good example. I mean, statistics has been around a long time, certainly before OR, right? A famous story of Danzig marching into the room with I don't know if he was marching, but, coming into the room late, the classroom. And I think he was a statistician. And there were 3 problems on the board and he thought they were homework questions. And so he went away to do them after the class, and he took him quite a while. And he went back to the professor and said, I'm really sorry this homework is so late. These were extremely difficult questions for me to do. And the professor said, what are you talking about? These were open questions I had just put on the board and no one had solved them before. So he was actually, that was in statistics, I believe. And so that's a classical field. So you could say, okay, well, statistics is just an older field. But then you bring up machine learning, and it seems like everybody knows what machine learning is without really knowing. And that's, far more kind of modern instantiation of a field. And so why does it seem that machine learning has made better strides? I think one thing is we tend to call operations research 47 different names. And whenever we think we haven't marketed it well enough, we dream up a 48th name. And I'm not sure that that really has done our field much good. I think the other thing is that machine learning kind of hit the ground running with applications in industry. And I think that operations research in the US had its beginnings in the military, but then, after World War II, maybe people didn't think about it quite as much. It was never really part of a mainstream civilian kind of a paradigm. Whereas in other countries where it is more widely, more common, Chile would be one, it has its applications in the mining industry, its origins, sorry, in applications in the mining industry. And I mean, mining is a huge part of Chile's GDP. So if you say operations research down there, a lot of people will know that. And the big universities, they all have industrial engineering slash operations research at them. So I think that it was somehow not made sufficiently mainstream after its introduction in the military setting. How are we going to change that? I mean, I think continued marketing. I think trying to continue to change the name is probably not good, but I think emphasizing to faculty that operations research, in the applied sense, is actually a good thing to be spending time on. I have tried quite tirelessly to get faculty at various schools to kind of put the journal on the list or whatever. And, that's been met with some sort of friction. Like, no, we want math of OR on the list, and we want, math programming, and we want operations research. And those are all fine journals, but they're all, a little bit more niche, a little more theoretical. And, faculty aren't being encouraged to publish in applied outlets. They're not being encouraged then to do applied work. That in turn, has implications in terms of what the students do when they get out, and are they doing real hardcore optimization when they graduate? And the answer is probably no, and it's kind of a vicious cycle. So, I mean, I don't want to accuse one person, but I definitely have feelings about this bridging the gap, and the gap is still not quite bridged. So I think that's some of the issue.
Fantastic. We have one more question from Matthew, Alexandra, so I'm going to read that real quick here. How do you bridge the prediction with the optimization in the class? When I try to scope applied problems with companies that have an optimization component, it seems like the real challenge is properly taking the partner's predictive models or forecasts that they are confident with and integrating those into the decision model. And of course, he says, love this session. Thank you. So thank you, Matthew. Alexandra, if you want me to read that again, let me know.
All right. So the question is how to bridge.
How do you bridge the prediction with the optimization in the class?
So is that so in the classroom, how do I incorporate statistics? Is that kind of the
Matthew, maybe you can jump in with a little bit of I think you're able to also ask your question live or expand on that. But the follow-up is when I try to scope applied problems with companies that have an optimization component, it seems like the real challenge is properly taking the partner's predictive models or forecasts that they're confident with and integrating those into the decision model. So how do you bridge the prediction with the optimization in the class?
I see. All right. So I would say in the classroom, I don't do too much with statistics. The students in operations research have to take at least one statistics course for the master's and or PhD. But I would say that we definitely have projects where we have to use statistical components and optimization components. And I would say that sometimes they feel more comfortable with statistics. And if you can start with a statistical model and you can sort of vet that, and they agree that that model that you've also looked at and they've looked at seems to be correct, then they would be more apt to also accept your optimization model. But I mean, then how we actually, so how we do that from maybe the implementation standpoint is, yes, simply trying to gain some kind of a, I would say trust, from the company through working with them on the statistical approach, and then saying, all right, well, now we can do better with the optimization approach. In terms of using statistical output from statistical models and optimization, I mean, that we would usually take as an output and we infuse it into the optimization models and inputs. We're doing that in the steel mill right now. And so those seem to be kind of, I mean, I would say activities where one kind of follows the other. We haven't done too much where there's a lot of back and forth. There are people who do that a lot, like in scheduling models. I know that with the Major League Baseball, they looked a lot at like this predictive analytics and where the fans might be on any given day. And, for example, I've had this good example in LA, people don't watch baseball on the weekends because they like to go to the beach. But in Cleveland, there is no beach. And so the stands are much fuller on the weekends, relatively speaking, right? So, then maybe scheduling home games Cleveland on the weekends, weekday games LA, and so forth. So I know that people have done this type of thing before. I'd have to maybe get a little more specific. You can certainly send me a follow-up, with some very specific question about how might you do this. But I think that they do go hand in hand, and we've done it, and certainly has been done. So yeah.
All right. There's a thank you from Matthew, and Eduardo, I think you wanted to add something before we
Yeah,
wrap up.
yeah, but very briefly, just to answer Matt's question as well. And this is something that Alexandra has already said. Typically, in those contexts, you normally input the forecasted results as an input to your model,
Mhm.
and that may seem simple, but things get tricky because then the question of optimality becomes okay. So does it matter to solve my problem to optimality, even if my inputs, which are my forecasts, have a certain degree of error? So within that, then now you have to balance.
Yeah.
I have a prediction error coming in from my
Yep.
forecasts, and then I may also introduce an error from my optimality gap. So, and this is something that not a lot of people think about, but it's something to keep in mind.
Yep.
As long as your inputs are forecasted, are coming from linear regression, Bayesian models,
Yep.
etc., you are prone to have an error. So optimality doesn't matter that much anymore.
Okay. Well, I think how I would answer that is two ways. One is that I still think that regardless, you're taking the numbers as good as you can get. So you may as well, with those numbers, solve the problem as well as you can. I don't think you should say, oh, well, these numbers aren't going to be perfect, so why bother about optimality? Now you've got kind of two levels of maybe, non-optimality going on instead of just one. That having been said, of course, you always have to balance, solution time against the kind of the practicality of when you need the solution. So the other thing, though, I would say is, of course, all models, and not just the data, but all models are wrong, but some are useful, as we hear a lot. And so at the end of the day, you do the best you can with the time you've been given, with the data you've been given, and so forth. Some people like sensitivities around it. Some people like resolves on a rolling horizon as the predictions become better. Those kind of things are helpful. But at the end of the day, no matter what you're doing, the question is, was the model useful? Did it actually get used? And is it more helpful in making decisions than if you didn't have a model? And so sometimes when people are poking holes at models and saying, we didn't consider this, you didn't consider that, it's like, yeah, but you were able to consider a lot more things than if you just sort of winged it. And what you can easily do is you can show a lot of companies will have a typical solution. How are they currently performing their operation? And you can show, all right, if I take the objective function as something we agree on, and I put your solution in the objective, and I put our solution in the objective, you can kind of see the trade-offs and see what's better. And in fact, a lot of times people will violate their own constraints. And so you don't even have to go as far as the objective. You say, well, that's irrelevant because your solution doesn't even satisfy your own constraints. So, I think that trying to simply show people who don't use quantitative modeling that, well, my solution might not be the best ever. There might be some failures in the modeling or the predictions, but on the other hand, it's a lot better than what you're currently doing. I think that that's very instructive. And then I think people start to see, that, well, okay, it's true, that maybe I could nitpick at your solution, but you're certainly doing a lot better than we're doing. So. And a lot more reproducibly. It's not just about the quality of solution. It's like the ease with which you can get it. Are you going to sit and spend 10 days, or are you going to be able to get it fairly quickly? And we did some modeling for the Coast Guard, and they brought up the fact they do, drug interdiction and so forth. And so it's like, okay, so you're sitting there and 30 zillion pounds of cocaine have just come in. You're trying to solve this model to schedule the deployment and the maintenance of your helicopter fleet. And you're going to do that. And you've got like these, this other stuff flying around your work environment. Like you'd rather just push a button, get an answer, and then look at it over and say, this looks reasonable. Let's go with it. And then there's also the reproducibility aspect. And that's one thing with the steel mill that comes up is there's different sets of rules depending on who is actually making the schedules. And so is that better than saying, well, we had a model that actually was pretty consistent in terms of implementing the rules? So.
Yeah. We should definitely schedule a part two to this webinar.
Yes, we definitely would love to have you back, Alexandra. I know we're over time, but our listeners are still tuned in, so I know they found this very insightful. Again, we will have to work on a part two. Thank you again so much for your time and for your insights and perspective on the topic. Um, we wish you all a wonderful afternoon or evening, depending on what time of day you're joining us today. Stay tuned for the recording on YouTube. And if you would like to get in touch with us, of course, or would like to get in touch with Alexandra as well, as she's offered, feel free to reach out to us and we will share her contact information as well. So once again, thank you very much, Alexandra, and thank you, Eduardo, for a wonderful interview. Have a great day, everybody.
Thank you for having
Thank
me.
you, everyone. Thank you,
Thank
Alexandra,
you.
very much.
Bye-bye.
See you around.